Your teacher today is Dr. Bosa, Science. Dr. Bosa is a teacher at the Science Foundation College, the best secondary school in Uganda. Today, 20th January 2021, we are going to study curved mirrors in geometrical optics, lesson 2 of 2. Our email is digitalteachersuganda@gmail.com. Our website is digitalteachers.co.ug. Here find notes, exams and their marking guides in physics, chemistry, biology, math and primary subjects. Or on YouTube website, in search type in Digital Teachers Uganda and enter. You will be given categories of videos in physics, chemistry, biology, math and primary subjects. Please subscribe to promote my videos. Subscription is free. The best secondary school in Uganda is the Science Foundation College. The best primary school in Uganda is Rock of Ages Primary School, Chiwanga, Mukono District. Relationship between focal length F and radius of curvature R of concave mirrors. Consider the reflection of a parallaxal ray AX parallel and close to principal axis of a curved mirror. Then FP is the focal length F. CP is the radius of curvature R. Cx is the normal to the mirror surface. Remember that all normals at any point on the mirror surface pass through the center of curvature C. If AX is close to P, then angle 2I is very small. Therefore, tan 2I is the same as 2I. And tan 2I is the same as XP over PF, giving us equation 1. Similarly, tan I is small, is approximately equal to I, and is equal to XP over CP. Substituting equation 2 in 1, 2XP over CP is the same as XP over FP. If we cross out XP on either side, then 2 over CP, but CP is R, is the same as 1 over FP, but FP is the same as focal length F. Cross multiplying, R is equal to 2F. Thus, the radius of curvature R is twice the focal length F. Mirror formula and sign convention. 1. Distances of real objects and images are positive. 2. Distances of virtual objects and images are negative. Concave or converging mirror formula. Consider incident ray OX on a concave mirror from a point object O placed along the principal axis, reflected in the direction XI, making an angle theta with the normal XC. Remember, the normal at any point on the surface of the mirror passes through the center of curvature C. The ray OP incident normal at P is reflected back along on path, and the point of intersection I is the image position. From triangle OXC, B is equal to alpha plus theta, giving equation 1. From triangle CXI, lambda is equal to B plus theta. Lambda here is equal to B plus theta, giving equation 2. Eliminating theta, we subtract equation 2 from equation 1. So alpha minus beta is equal to beta minus lambda. Correcting like terms, alpha plus lambda is equal to 2 beta. If x is close to P, it means that angle alpha, beta, and lambda are very small. Then angle alpha is equal to tan alpha, which is xp over u. Also beta is equal to tan beta, which is xb over r. Also lambda is equal to tan lambda, which is equal to xp over u. Substituting these ones in equation 3, then xp over u plus xp over v is equal to 2xp over r. Crossing out xp, when we cross out xp, then we get 1 over u plus 1 over v is equal to 2 over r. Since r is equal to 2f, when we substitute 2f for r, then 1 over u plus 1 over v is equal to 1 over f. And this is the mirror formula for concave mirror. Convex or diverging mirror formula. Consider an incident ray OX on a convex mirror from a point object O along the principal axis reflected along xk, making an angle theta with the normal xc. Remember, all normals on a curved mirror pass through the center of curvature. The ray OP, incident normally at P, is reflected along its own path, and the intersection I is the image distance. From triangle XIC, beta is equal to theta plus lambda, or theta is equal to beta minus lambda in equation 1. From triangle OXI, alpha plus beta is equal to 2 theta. From equation 1 and 2, eliminating theta, we substitute for theta with beta minus lambda. Therefore, alpha plus beta is equal to 2 into beta minus lambda, or alpha minus beta is equal to negative 2 lambda. If x is equal to P, then alpha, beta, and lambda are very small. Therefore, alpha is equal to tan alpha, beta is the same as tan beta, and lambda is the same as tan lambda. Alpha then will be equal to xp over u. Beta will be xp over negative v, because I is virtue. Lambda is equal to tan lambda is equal to xp over negative r because the center of curvature is virtual. Substituting alpha is equal to xp over u, beta, but is negative, so the negative will cancel. You have xp over v will be equal to negative will cancel, will be equal to 2xp over r, or 1 over u plus 1 over v is equal to 2 r. Since r is equal to 2f, then 1 over u plus 1 over v is equal to 1 over f. The same equation as for the concave mirror. Formula for magnification. Linear magnification m is equal to image height over object height is equal to image distance over object distance. Proof of the magnification formula. Consider the incident ray AP to the pole of a concave mirror from an object of height h, placed at distance u from the mirror and reflected back, making the same angle with the principal axis to image I of height h1, located at distance v from the mirror as shown. The ray AP makes an angle theta with the normal OP. Then from triangle APO, tan theta is equal to h over u. Also from triangle IBP, again tan theta will be equal to h1 over v. From equation is 1 and 2, tan theta is equal to h over u is equal to h1 over v. By rearrangement, v over u is equal to h1 over h. Thus, the magnification m is equal to v over u is equal to h1 over h, or is equal to image distance over object distance, and is equal to height of the image over the height over the object. The relationship between m, v, and f. From 1 over f is equal to 1 over u plus 1 over v. When we multiply by v throughout, we get v over f is equal to v over u plus 1. But v over u is equal to m, therefore v over f is equal to m plus 1, or m is equal to v over f minus 1. Example 2. An object is placed 10 centimeters in front of a concave mirror of focal length 15 centimeters. Find the position of the image and magnification. From 1 over f is equal to 1 over u plus 1 over v. 1 over 15 is equal to 1 over 10 plus 1 over v. Therefore, v is equal to negative 30. Negative v because the image is virtual. Magnification is equal to v over u is equal to 30 over 10, which is equal to 3. Example 3. The image of an object in a convex mirror is 6 centimeters from the mirror. If the radius of curvature is 20, find the object distance. For a convex mirror, the radius of curvature is negative, since the center of curvature is behind the mirror. Therefore, f is equal to negative r over 2, which is negative 20, over 2, which is equal to negative 10. Always, a convex mirror forms virtual images. Therefore, v is negative 6. From 1 over f is equal to 1 over u plus 1 over v. 1 over negative 10 is equal to 1 over u minus 1 over 6. U is equal to 15. Therefore, object distance is 15 centimeters. Example 4, show that object and image coincide at the center of curvature. The object's distance at the center of curvature u is equal to r. F is equal to r over 2. From 1 over f is equal to 1 over u plus 1 over v. 2 over r is equal to 1 over r plus 1 over v. 1 over v is equal to 2 over r minus 1 over r. 1 over r is equal to 1 over v. V is equal to r. Therefore, image and object coincide at C. Number 5, a concave mirror forms a real image 5 times the size of the object. The object and the screen are moved until the image is 5 times the size of the object. If the shift of the screen is 30 centimeters, determine Roman 1, focal length of the mirror. Roman 2, shift of the object. Solution. Roman 1, from m is equal to v minus 1, v is equal to mf plus 1. v1 will be equal to 3f plus 1. v2 will be 5f plus 1. v2 plus v1 is equal to 30 is equal to 2f. F is equal to 15. Roman 2, u is equal to f over m plus 1. u1 would be equal to 15 over 3 times 15 plus 15, which is equal to 20. Also, u2 would be equal to 15 over 5, which is 3 plus 15, 18. u2 minus u1 is equal to 20 minus 18. Therefore, the object shift is 2 centimeters. Thank you so much for listening to this video. Our email is digitalteachersuganda@gmail.com. Our website is digitalteachers.co.ug. Here find notes, exams, and their marking guides in physics, chemistry, biology, math, and primary subjects. Or on YouTube website, in search, type in Digital Teachers Uganda. You'll be given categories of videos in physics, chemistry, biology, math, and primary subjects. Please subscribe to promote my videos. Subscription is free. The best secondary school in Uganda is the Science Foundation College. The best primary school in Uganda is Rock of Ages Primary School.